Okay, on what basis we are going to verify with we are going to set whether it is a best algorithm means based on the time as well as the space complexity. So in the last class we already discussed time complexity means how much of the time that algorithm will be considered in order to complete its execution. Okay, that is nothing but the time complexity. Okay, so time complexity is depends upon the number of statements we are written for the algorithm. Okay, that is the first point. And second point, if that algorithm contain any iterative statements, any control flow statement, okay, or any looping statements, okay, any non-primitive data types, based on these, the algorithm will have their own time complexity. Okay, two factors now. One thing, how to find out the time complexity for a given algorithm is the time complexity is depends upon two factors. One is how many lines of code or how many lines of steps we return for the respective algorithm. And second point, if that algorithm contain any usage of iterative statement like as take for loops, while loops, switch statements, okay, or you can able to use any unions, structures. Okay, based on this, even though the algorithm contains small lines of code, small lines of steps, if you contain okay these type of iterative control flow statements, the algorithm, the time complexity of algorithm may be vary. Am I clear? So how to find out the time complexity? Okay, as already said in the last class, we have to read the algorithm line by line, and we have to analyze how much of the time the algorithm or the lines in the algorithm will take. For example, you written a factorial algorithm. Okay, starts from start to stop. Okay, you written like 5 or 6 statements. Okay, as you are performing factorial, of course, we should include a for loop. Am I clear? You should aware how that for loop will be executed. Am I clear? For example, in your algorithm, if you are using switch, am I clear? You should aware how that switch will be works. Because, for example, for loop. Okay, for loop contain 3 fields. One is initialization of the variable, condition, and second one is increment or decrement. Okay, you should know what is the flow of the for loop, or flow of the while loop, or flow of the switch case, whatever you written in your algorithm. Because we have to count every step as 1 unit of time. Please remember this point. First, we have to verify the number of lines the algorithm contains. And start from the first line, we have to read. Okay, how much of time that particular line will be taken. For example, the first line in the algorithm is just declaration or initializations of the variable. Okay, then it will consider 1 unit of time. Okay, in the second statement, you written a for loop. Okay, in that for loop, you written some set of statements. Okay, the set of all that statement we can able to analyze and how much of time that every line in the for loop will take. Am I clear? So start from the start of your algorithm until end. We have to read every line and we have to consider time in the units. I will show you the algorithm, no problem. Okay, but first we have to go for the theoretical. So time complexity is a computational complexity that describes the amount of time it takes to run the algorithm. Okay, the time complexity of an algorithm means starts from first line to end line. All those lines has to be summed. For example, first line will take 1 unit of time, second line will take 3 units of time, fourth line, okay, who contain for loop, it will take n units of time. Because in the for loop we have a condition I less than n. Who doesn't know what is n? So the for loop may take n units of time. So we have to perform every line has to be analyzed. We need to identify number of units of time that every line has to be considered. And finally, we have to add up all those units of time of every line. So finally, whatever the result we are getting, that should be considered as time complexity for that algorithm, entire algorithm. That's the point they described here. Describe the amount of time it takes to run the algorithm. Why you are taking line by line units of time? In your algorithm, you may have 10 lines. Every line may have its own time complexity. It have their own units of time. Am I clear? Sum of all the 10 lines unit of time, it will give the time complexity. Am I clear? This time complexity will say you how much of time the entire algorithm will take to run it or to perform its execution. Am I clear? So based on that, we can able to decide this so and so algorithm is the best one. Am I clear? As we discussed in the last class, you can able to write n number of algorithms for the same problem definition. Am I clear? So what we have to do is, in order to reduce the time taken to run the algorithm, the number of lines in the algorithm should be minimum, and if it is necessary, then only go for the control flow statements or iterative statements, okay, or any conditional control statements. That's it. I mean, because they may have increased the chance of taking more time. I mean, even though the code length of the code has been reduced, but they have to be performed iteratively. Hence, the algorithm, okay, will have their more time complexity. I mean, so all these are the everything. Thus, the amount of time taken, the number of elementary operations performed by the algorithm are taken to differ at most. All these are the theoretical. That's what we discuss. Every line of your algorithm may contain different statement. It may be declaration statement, it may be initialization statement, or it may be simple any arithmetic expression, or it may be any what we discuss, for loop, while loop, any statement, or your statement in the algorithm may be a function calling statement. Am I clear? So every step what we written in your algorithm may be different. Am I clear? So according to that, the time taken by every step in the algorithm is also different. So what we have to do is, we have to sum up all the units of time taken by every line of your algorithm, and finally we have to calculate, and we have to say this is the time taken by this algorithm to complete its execution. Am I clear? So in order to go for the clear idea, let's go for an example first. Yes. Okay, so see that what we discuss here. The time complexity of an algorithm is the total time taken. Okay, what is meant by total here? Number of units of time taken by every line of your algorithm is considered as total. I mean, we will not miss any line. We will not miss, even though it is a simple declaration, even though it is a simple function calling statement. Okay, we doesn't miss any line of your algorithm. I mean, because that single line may take some units of time. I mean, if you miss any simple statements, you may feel that these statements are simple. Okay, is it necessary to take the time? Yes, of course, we have to take every line. We need to consider every line of your algorithm. Am I clear? And we have to consider that at the time you are going to calculate the total time of the entire algorithm. Am I clear? So let's go for a small example here. Okay, a small example. We'll discuss a couple of examples now. And please remember, whatever the program, okay, we written in this entire concepts of data structure, okay, it is better to go for the algorithm first. Okay, so whenever we written an algorithm, for every concept, we need to calculate time complexity. I mean, the time complexities will not be by hearted. I mean, we need to practice taking a small examples initially and go for merge sort, quick sort. Okay, we have the algorithms for different concepts in the data structure. Okay, so we need to understand the algorithm first. Okay, every line of the algorithm. Then we have to calculate the time complexity. Okay, without knowing how the algorithm will work, we will not go for finding the time complexity of every line. For loop undi. For loop ela work avuddo meeku teliyunda. Okay, you should not identify what is the time taken by that for loop. I make clear. If you doesn't know how the function calling statements will be executed, you doesn't go for calculating the time complexity. I make clear. So you should aware the concepts first. Concept is nothing but how the program or how your algorithm, okay, will works. That you have to be familiar first. Then only you can able to understand how many units of time that particular line will be considered. As this is a simple example, let's start this one. Okay, so this is the sample code we have. Okay, sir, you already said that we are going to find out the time complexity for algorithm. Then why you are taking a code? Here, algorithm is the initial thing, initial phase before going for the coding. Am I clear? I mean, we are writing the algorithm in a stepwise, but we are writing a code in a sequential way by using the braces and everything. Okay, so most probably you can able to go for algorithm and perform the time complexity, or go for the pseudocode, or go for the direct any programming code and identify every statement. Okay, and identify how the execution of the every statement will done. Then go for calculating time complexity. మీరు ఎలాగైనా చేయొచ్చు. Algorithm ke time complexity find out చేయాలని ఏం లేదు. Okay, you can able to take any pseudocode, or you can able to take directly the C programming, any C program, understand the way of executing of every line, then go for time complexity calculation. Am I clear? So as it is a simple 2 lines of code, okay, let me explain how we are going to consider every line and how to find out the time complexity for every line. Am I clear? So see this one. In this example, we declared function sum int a and int b. Okay, in that particular sum function, we are returning some a plus b. Am I clear? So we have to start from the first line of a code. Am I clear? In the first line of a code, in order to execute this particular statement, have you required any time? No. Why? Because this particular line doesn't have any operation, doesn't have any declaration, I mean, it doesn't have any function state calling statement, nothing. Simply we are declaring our function sum. I mean, it contains 2 variables, int a comma int b arguments. I mean, for that it doesn't take any time. Okay, it doesn't require any system time. I mean, but if you go inside of that particular sum function, okay, we have a statement. What is that? We are written a plus b. So we need to perform a operation here. What is that? We have to consider what is the value of a. We are going to consider what is the value of b. Then you can be able to perform a plus b. So we require some 1 unit of time to calculate this additional operation. One task. If you completely read the statement, it is returning a plus b. In order to perform the calculation, summation or addition between a plus b, it is considered as 1 unit of time. You may consider 1 hour or 1 day or anything. In general format, we are taking 1 unit of time is required in order to perform this a plus b operation. That is the first task. In the same statement, that is the first task. Second task, we are returning. Returning means whatever the result we are getting for this a plus b addition, we are going to be returned from this user-defined function sum to somewhere. Maybe it is returning to main, or maybe it is returning to where the sum function is being called. So in order to do that, in order to return the resultant value, you may consider again 1 more unit of time. So for this particular statement, you may require additional 1 unit of time. After this return statement, doesn't have any other expressions or any statements in our code. Completed. So the total time taken in order to execute this particular piece of code is 2 units of time. That's it. A simple example. So what you are going to do is either you are taking an algorithm or you are going to take any sample code, starts reading from the first line of the code. Sir, shall we take header files also? No. / include stdio.h, okay, or math.h, okay, including of header files. For that, we doesn't calculate the time, because those may be mandatory for every code, every concept. Am I clear? So other than header files, other than the preprocessed directives, okay, start from the main. Whatever the code you have, every line of a code you have to be read. You need to understand what is the meaning of that line. Then you can able to understand what is the units of time that particular line will be taken. For example, if you take an algorithm, start from the step 1. Okay, start from the step 1. If you have any initialization declarations, go for the step 2. Whatever the statements we have up to the end of your algorithm, okay, know the meaning of every line. If you doesn't know the meaning of the every line, okay, obviously the time complexity you will get will be different. Okay, so you should aware the concepts first. Okay, how to write, so what is the syntax of so and so while loop, so and so function return statement, and everything. Then only it is easy for you to calculate the time complexity. Okay, so for this piece of code of 2 lines of code, okay, the time taken is 2 units. 2 units. And one more thing here is, sir, if I given the integer values of a and b, okay, or if I given any other data type like float values for a and b, is the time complexity is vary? No. No. Even though whatever the data type, whatever the type of values you given for the variables a and b, I mean, the operation is same. Am I clear? The operation is same. You are going to perform an addition. Who doesn't concern about what is the type of A or what is the type of B. Am I clear? We are going to focus on how much of time taken to perform its operation. Am I clear? Integers తీసుకుంటే ఒక విధంగా, fractional values తీసుకుంటే ఒక విధంగా, operation జరగదు కదా. You are going to perform addition in between A and B. Who doesn't concern what is the values of A and B here. Am I clear? Please remember this point. In order to perform addition between A and B, who doesn't concern what is the type of values of A and B. Okay, every data type for A and B, every value whatever you given for A and B, the time taken it should be 1 unit. Am I clear? And in order to return the resultant value from our some user defined function to main, okay, we are going to consider 1 unit of time. Am I clear? A simple example here. For example, you are returning this A and B resultant from the sum function to, for example, you have one more user defined function. Let us take CSCB. CSCB is one more function you have. Am I clear? We are going to return this result of A and B to this CSCB. From sum function to CSCB, it will take 1 unit of time. For example, again in the CSCB, we are returning the value from CSCB to main. For example, to the main function we are returning. Am I clear? So from here, CSCB to main, again we are taking 1 unit of time. Because again we return a return statement. We mention a return statement in the CSCB also. So for that also we are taking 1 unit of time. Am I clear? So here 1 unit of time for returning from sum to CSCB, from CSCB to main, 1 more unit of time. So at the time you are going to find out the entire program time complexity, then we have to consider that 1 unit of time from CSCB to main, 1 unit of time from sum to CSCB, 1 unit of time from performing the addition. So total 3 units. Hope you understand what I am saying. You need to read every line of the code, even though you have the multiple functions in your entire program, even though you have some predefined functions, you may have some user-defined functions. Okay, individually we have to calculate first. Okay, then we have to find out summation for every line of a code. Whatever the resultant value we are getting, that should be considered as a time complexity for the entire program or for the entire algorithm. Okay. We may not get exact clear idea by seeing only one example. Okay, for every concept what we discuss in the entire syllabus, okay, for everything you should have algorithm. Okay, for every algorithm, try to find out the time complexity. Actually, calculation of time complexity is not the concept in data structure. But at the time you are discussing the concepts, I can explain how to find out the time complexity for so and so concept. Actually, as we discussed in the last class, you have a subject of DA, design and analysis of algorithm. Okay, in that subject, okay, you should have some techniques to find out the time complexity. But anyhow, while you discuss the concepts in the data structure, we will discuss how to get the time complexity for the so and so algorithm. Okay, so the total unit of time taken by this particular example 1 is 2. One is for calculation of operation and one is for returning the value. Okay, and one more thing here, what is meant by this constant time complexity? Constant time complexity is, there are some algorithms or there are some examples like this, where the time taken by that particular algorithm or code will not be changed. Will not be changed. Why I am saying will not be changed is, even though you are changing the values of A and B, as we discussed earlier, even though you given integers initially, you get two units of time is the time complexity for the entire program. Okay, you given float values for A and B. Okay, in that situation also, the time taken by this example 1 is only 2 units. Means the time complexity is not dependent on the data type of the variables. I make the data type of the variables. Hence, these type of examples we are going to find out 2 units of time. I make clear. So this 2 is considered as a constant time complexity. See the definition what they given for the time complexity. If any program required fixed amount of time for all input values, whatever the type of value you are going to give for that program, the time complexity of the program or the time complexity of the algorithm will not be changed. Hence, those type of time complexities is considered as constant time complexity. Okay, the name indicates that a constant time complexity. Time complexity of the algorithm or time complexity of the program will not be changed. Okay, why it is not changed? On what basis you are saying it is a constant time complexity? Why it is not changed? Because even though you given the different type of input values, okay, the time taken by the particular algorithm or the time taken by the particular program will be same. Am I clear? So this is the example for the simple example for the time complexity, constant time complexity. Is it clear now? You can write running notes. You can be able to copy this code. Clear, everyone? If you have any doubts, you can raise the voice. Okay. So let's go for one more example. Okay. If you get these 2 examples, clear idea. Okay. Then you will get how we are going to find out the time complexity. Okay. So let's go for second example here. Okay. In the second example, we have the length of code is slightly larger. Okay. Here in the example we have cost, repetition, and the total. Okay, the total time. So what we are going to do starts from the first line of a code. We have to read, we have to understand, okay, and we have to find out the time taken by the statement. Am I clear? First we have to read. You need to understand how that particular line is going to be executed. What is the meaning of writing that particular line in the code? Okay, then we will go for finding the time complexity. 1 second. Okay. Okay. So starts from the first line. The first line is nothing but a function definition statement. Okay, simply you are going to write our function. Okay, it contains some arguments. Okay, for writing this statement, it doesn't take any time. Simply we are writing the name of our function. Okay, then go for into that function. Okay, the first one is a initialization statements. Okay, for declaration or initialization statement. Okay, we are taking the constant time. So the cost, okay, it are nothing but the time taken for this particular line is only 1. Okay, only 1. Even though you have the multiple variables initializations, okay, it will take only 1 unit of time. I make clear. Time it will take only 1 month, but the space it may take more. Okay, why I'm saying space is we have, for example, it's here we have one variable sum equal to 0. We have one more variable I. So what in the memory locations of the system, what we have to do? We have to create a memory location for variable sum. There we have to store our value is 0. Similarly, for the variable I, we are going to create a memory location. Okay, whatever the user given value for I, it is been stored here. Am I clear? So at the time you are finding space, means the amount of memory required, we have to take this is 1 unit and this is second unit. Am I clear? Space is 2 units of 2 memory locations we require. But the time reading of this entire line will take only 1. Even though if you have 100 or 1000 of variable declarations or initializations, the time taken to read entire thing is only 1. మన దగ్గర 10 variables only 10 initializations చేసామని 10 అని రాయకూడదు. The entire thing it will take 1 unit of time, because we are not know what is that 1 unit of time, whether it is 1 hour or 1 day, it doesn't know. So as a format we are taking 1 unit of time. Then go for the next line. Okay, for this next line, okay, initially what is the cost? Okay, cost in the sense, for this we have to read 1 unit. For this we have to read 1 unit. For this we are going to read 1 unit. 3 different fields are there for this for loop. So initial assumption we are taking 1 unit, 1 unit, 1 unit. But if you understand, this is a for loop. Okay, what is the execution flow of for loop? What is the execution flow of the for loop now? First we have to read the initialization, then we are checking the condition. I will highlight it. First we have to read the initialization, then we will go for the condition. Okay, 0 is less than n. Then we are going into the for loop and finding this particular operation. This operation is been performed, then we are coming back to the for loop and performing the increment or decrement. So in this example we are going to perform increment of the value I. Now I value is 1. Now again we are going back to the condition, 1 is less than n. So we are coming back, we are going into the for loop. So this flow, how many times this particular for loop is being repeated? Okay, how many times every statement in the field of the for loop will be repeated? That we need to identify. And according to that we need to write the time complexity. But again I have to be repeat, please listen carefully. As this is a for loop, initially we assumed that the cost or the time taken for this for loop is, as it is containing the 3 fields, initialization, condition statement and increment or decrement. We are assuming this is for 1 unit, this is for 1 unit and this is for 1 unit. Initially we may assume that, but you should know what is the execution. మనం ఈ టైం కాంప్లెక్స్ ఎందుకు ఫైండ్ అవుట్ చేస్తున్నాం? ఆ పర్టికులర్ ప్రోగ్రామ్ ఎగ్జిక్యూట్ అవ్వడానికి ఎంత టైం పడుతుంది అని తెలుసుకోవడం కోసం కదా. అంతేగాని ప్రతి లైన్కి 1 యూనిట్ 1 యూనిట్ 1 యూనిట్ అని ఎన్ని లైన్స్ ఉంటాయి అన్ని యూనిట్స్ అని రాయకూడదు. You should aware the flow of the particular statement. How many times that particular statement is being repeated in your program. Based on that, we need to write the number of units of time. Please understand. If you come this for loop, initially I equal to 0. How many times this I equal to 0 is being executed? Only 1 time. I equal to 0 అనేది ఒకసారి అవుతుంది. Initially we given a value 0 for I. So what happened in the memory location of I? Initially the value of I is being placed with 0. I equal to 0 అనేది ప్రతిసారి అవుతుందా? No. I value is been updated every time. But I equal to 0 అనే స్టేట్మెంట్ ఎన్నిసార్లు ఎగ్జిక్యూట్ అవుతుంది? ఒకసారి. So as in the repetition we are going to take 1 unit of time for I equal to 0. Now please follow my words clearly. I equal to 0 అనే స్టేట్మెంట్ ఎన్నిసార్లు ఎగ్జిక్యూట్ అవుతుంది? ఒకసారి అవుతుంది. ప్రోగ్రామ్ మొత్తం ఎగ్జిక్యూషన్ I equal to 0 అనేది ఒకసారి అవుతుంది. నువ్వు ఇంకోసారి ప్రోగ్రామ్ ఎగ్జిక్యూట్ చేసావు అనుకో, అప్పుడు I equal to 0 ఇంకోసారి ఎగ్జిక్యూట్ అవుతుంది. Clear? But entire execution of a program, I equal to 0 is the initialization statement. So the time taken for that particular statement is only 1 unit of time. Okay. Then go for next field. What is the next field? I is less than n. This particular statement I is less than n అనేది ఎన్నిసార్లు ఎగ్జిక్యూట్ అవుతుంది? I is less than n starts from I equal to 0 1 time. For example, let us take n value is some 5 now. Let us take n value is 5. Okay, starts from 0, 0 is less than 5, starts from next incremented to 1, 1 is less than 5, 2 is less than 5, 3 is less than 5, 4 is less than 5, 5 is less than 5. No, we stop. So starts from 0 to to n value reaches, I value is reaches to n, we are repeating the condition. We are going to check the I value repeatedly with n value. Am I clear? So this particular statement is being, this particular field in the entire for loop, the second field, okay, conditional controls, condition checking statement, it is going to be executed in n plus 1 times. Because n value, I value is reaches to 5. In that situation also, we are comparing with 5. 5 is less than 5 or kaada anedi kuda verify chestam. Am I clear? So now it will take n plus 1 units of time. Okay. Similarly, what is the third field? Increment statement. Initially I equal to 0. In the next step, I is 1. In the next step, I is 2. So I is 3, 4, 5. Am I clear? At the time I is 5. Okay. Okay. This 5 is being verified with one value of 5. Okay. It is not less than. So we stop. We will not go for further increment. Am I clear? So number of times this I plus plus is being performed is n times. Am I clear? So we have to perform the summation for this statement. Our for loop statement is total time enta? N plus n, 2n, 1 plus 1, 2. So 2n plus 2 is the time taken by that for loop. ఇప్పుడు చిన్న క్వశ్చన్ అమ్మా, ఇప్పుడు ఈ ఫర్ లూప్ మొత్తం స్టేట్మెంట్ మొత్తం కూడా ఎంత టైం తీసుకుంటుంది అనేది మనం డిసైడ్ చేయాలంటే ఏ వేరియబుల్ మీద డిసైడ్ అయి ఉంటుంది? ఆర్ వాట్ వేరియబుల్ దిస్ టైం కాంప్లెక్సిటీ ఆఫ్ దిస్ ఫర్ లూప్ విల్ డిపెండ్స్? ఎనీవన్? Anyone? This particular for loop, okay, we will get 2n plus 2 is the time complexity for the for loop. Okay, and what variable the time complexity of the particular for loop will depends. Anyone in the class? Yes, sir. Question అర్థమైందా? ఇప్పుడు మనం ఫర్ లూప్ కి టైం కాంప్లెక్సిటీ ఫైండ్ అవుట్ చేసాం. We get that 2n plus 2 is the time taken by the for loop to complete the execution of the for loop. Am I clear? If you want a constant value, let us take 10, 15, okay, like that, on what basis? A variable may depend on the I may depend on the n may depend on the
n, sir.
n. Who said that answer? Okay. So the time complexity of that particular for loop will depends upon value of n. మీరు ఇప్పుడు n వాల్యూ నేను 10 తీసుకున్నాను అనుకోండి. If I take n value is 10, then that particular statement will have the time complexity of 2 into 10 plus 2, 22. If I take the the value of n is 5, then the time complexity of that particular for loop, okay, will have 2 into 5 plus 2. Am I clear? So in this example, okay, in this example, can I say constant time complexity? No, it is not constant time complexity, because based on the value of n, the time complexity of the code will be different. ఇంకా మనం కంప్లీట్ అవ్వలేదమ్మా, మొత్తం కోడ్ని ప్రతి లైన్ని మనం రీడ్ చేయలే. ఓకే, ఓన్లీ ఫర్ లూప్ వరకు రీడ్ చేసాం. ఓకే, దిస్ ఎంటైర్ ప్రోగ్రామ్ పీస్ ఆఫ్ కోడ్ వాట్ ఎవర్ యూ టేక్ ఇట్ హియర్, okay, it is not a constant time complexity. ఎందుకు? n value ను మార్చుతున్నాను అనుకోండి, if you change the value of n, then the time complexities will be different. I mean, we will discuss that point. Okay, so let's go for the next statement. What we have in the for loop, number of times that particular statement will be executed. We need to get the value of sum here. We need to get the value of what is this a of I. A of I means we are getting some we are going to access some value from array A. So initial assumption, we are taking 1 unit of time for this sum. We are taking 1 unit of time for performing addition in between these two. Sum అనేది ఒక వాల్యూ ఉందమ్మా, దానికి రావడానికి a of I is one value. We are going to get that from an array A. Okay, for that constant 1. Addition between these two, 1. So initial assumption, we are taking it is as 2. One is for getting the values of sum and a of I. One is for getting the performing the addition between sum and a of I. Initial assumption is 2, but if you observe this particular statement, this entire statement, it is not outside the for loop, it is inside of the for loop. Because why? Because every time after checking the condition in the for loop, you are entering into the for loop. Am I clear? And you are performing sum equal to sum of a plus. Am I clear? Then I value is updated. I value has been verified with and again we are coming to the sum. We are going into the for loop. Again we have to perform sum equal to sum of a f. Am I clear? Again we are going back to the for loop. I value is incremented. I value has been verified with condition. It is true. Again we are going into the for loop. Again we are performing sum equal to sum of a plus sum. So whatever the statements we return inside of the for loop, it should be repeatedly performing. Am I clear? Number of times, how many times it is performing? Until the condition holds true. If the condition is failed, we will not entering in the for loop now. So we are depends upon the condition. So number of times the condition is true, n times. In the example, n value 5 is 4 is less than 5 varaku, we are entering into the statement. We are entering into the for loop and we are executing what the statements written in the for loop. Once if I value is reaches to 5, 5 is not less than 5, then we are not going into the for loop. So the number of times this entire statement need to be executed is considered as n. మీకు అందుకే ఇక్కడ సపరేట్ చేశాను కాస్ట్ రిపిటేషన్ అనేది సపరేట్ చేశాను. ఫస్ట్ స్టేట్మెంట్ చూడండి, ఇక్కడ 1 ఉంది, ఇక్కడ 1 ఉంది. సెకండ్ స్టేట్మెంట్ చూడండి, ఇనిషియల్ అజంప్షన్ లో 1 1 1 అంటుంది, బట్ యాజ్ ఇట్ ఈస్ ఏ ఇటరేటివ్ స్టేట్మెంట్ we need to do the repeatedly the same task. So the total time is been calculated in the form of n. Am I clear? So whatever the statements we return inside of the for loop also, okay, we have to repeatedly perform that in n times. Am I clear? In the last statement, returning of sum. Okay, if you return this return sum statement in the for loop, again the time taken by that statement also n. But fortunately, we return this statement, return sum, outside of the for loop. So obviously, this will take only 1 unit of time. Okay, so like this, every line we need to identify. Okay, every line you need to understand how the execution flow will be performed. Then అందుకే డేటా స్ట్రక్చర్స్ సబ్జెక్ట్ ముందు మీకు C++ PPSC సబ్జెక్ట్ పెట్టింది. You should know the basic programming concepts. ఇప్పుడు వరకు మనం డేటా స్ట్రక్చర్స్ లో ఏదైనా ఒక కాన్సెప్ట్ ఇంప్లిమెంట్ చేసి దాని టైం కాంప్లెక్సిటీ క్యాలిక్యులేట్ చేయలేదండి. శాంపుల్ C ప్రోగ్రామ్ తీసుకొని దాన్ని ఎలా టైం కాంప్లెక్సిటీ ఫైండ్ అవుట్ చేస్తారో ఎగ్జాంపుల్ చెప్తున్నా అంతే. అదే ఇప్పుడు మీకు మెచ్ సార్ట్ ఉంది, పిచ్ సార్ట్ ఉంది, బబుల్ సార్ట్ ఉంది. ఓకేనా, దాని కాన్సెప్ట్ వేరు. Those concepts are different. Okay, according to their concept, we are writing the code. According to the code, every line need to be read. Okay, we need to examine how much of time every line has to be considered. Then we will get the total time. Okay, searching operation ఉంది, లీనియర్ సెర్చ్ లేదు బైనరీ సెర్చ్. ఆ కాన్సెప్ట్స్ ఎలా వర్క్ అవుతాయో ఫస్ట్ మనకు తెలియాలి. Then we have to write a code or we have to write an algorithm. Okay, for every line of the algorithm, we will go for the finding of time complexity. So let me complete this example. So for this statement, it will take 1 unit of time. Okay, now what we have to do is we need to perform these type of calculations. 1 plus n plus 1 plus n, make it as a 2n plus 2. Then find out summation of all those things. Okay, so we are going to consider after performing summation, 4n plus 4 is the total time required in order to complete the execution of this particular program. So that is nothing but this is the way we are going to identify the time complexity. Then మీరు ఏ అల్గారిథం రాసినా, ఏ కాన్సెప్ట్ రిలేటెడ్గా మీరు అల్గారిథం రాసినా ప్రొసీజర్ మాత్రం ఇదే. ఈ టైం కాంప్లెక్సిటీ ఎవరు ఎక్స్ప్లెయిన్ చేసినా, మీరు నెట్లో చూసినా, ఎక్కడ చూసినా దిస్ ఈస్ ద వే. మీకు అర్థం కావాల్సింది ఏంటంటే మీరు రాసిన అల్గారిథంలో కానీ వాట్ ఎవర్ ద కోడ్ యూ రిటర్న్, okay, you should await the execution of every statement. Then whatever the code you written, okay, you need to understand every line. You should know the sequence of execution. Then ఇప్పుడు ఈ ఫంక్షన్ నుంచి సమ్ ఆఫ్ లిస్ట్ అనే ఫంక్షన్ నుంచి మీరు ఇంకో ఫంక్షన్ కాల్ చేశారు అనుకోండి, మళ్ళీ టైం కాంప్లెక్సిటీ అక్కడి నుంచి ఆ పర్టికులర్ ఫంక్షన్కి వెళ్ళింది. అక్కడ ఉన్న వాల్యూస్ అన్ని అక్కడ ఉన్న లైన్స్ అన్ని రీడ్ చేసింది. Again come back to this. Right? We will not miss any statement. Okay, not even this return statement also. ఇలాంటి సింపుల్ రిటర్న్ స్టేట్మెంట్ అంటే ఏంటి, మనం అక్కడే క్యాలిక్యులేషన్ చేయం, అక్కడే మనకి పెద్ద పెద్ద కండిషన్స్ ఏమి లేవు. సింప్లీ యూఆర్ రిటర్నింగ్ ఎ వాల్యూ ఫ్రమ్ వన్ ప్లేస్ టు అనదర్ ప్లేస్, మీన్స్ from one function to another function. Even we are returning the value also, we are consuming 1 unit of time. That is also be considered while you calculating the total time taken by the entire program. సో మీరు ఏ కాన్సెప్ట్కి అల్గారిథం రాసిన ప్రొసీజర్ ఇదే అమ్మా. అదే మీరు బై హార్ట్ చేయాల్సిన ప్రొసీజర్ ఏమి ఉండదు. ఓకేనా, ఈ ప్రొసీజర్కి పారాగ్రాఫ్స్ ఏమి ఉండవు. సో నౌ I will discuss the last point here. So what is meant by this linear time complexity? Linear time complexity, till now we see in the constant time complexity. Okay, irrespective of the input values, the time complexity of the program will not be changed. This is the example, constant time complexity. But here, this program have constant time complexity. 4n plus 1 is a constant value. Okay, this will be changed every time. The time complexity here, 4n plus 4, will be changed every time. On what basis? On the base of n value. On the base of n value, the time complexity of this particular piece of code will be changed. If I given n value equal to 10, the time taken by this program is 44. If you take n value equal to 2, the time taken by this particular program is 4 plus 8 plus 4. 1. So those type of algorithms or those type of sample code, pseudo code, okay, whose time complexity is depends upon any variable, is considered as linear time complexity. Okay, ఈ టైం కాంప్లెక్స్ మనం జనరల్ గా రాస్తామంటే 4n plus 1 అని రాయకుండా O of n అని రాస్తాం. O of n, big O. What is this big O? Okay, అది నేను నెక్స్ట్ క్లాస్ లో చెప్తాను. జనరల్ we are writing this one as O of n. మనకి 3 different ఫార్మాట్స్ ఉంటాయి, నోటేషన్స్ ఉంటాయండి. వన్ ఇస్ ద బెస్ట్ టైం కాంప్లెక్సిటీ, వర్స్ట్ టైం కాంప్లెక్సిటీ, ఓకే, యావరేజ్ టైం కాంప్లెక్సిటీ. ఓకే, బెస్ట్ మీన్స్ ద మినిమం అమౌంట్ ఆఫ్ టైం దట్ algorithm will take. Best algorithm, best time complexity. Okay, average means on a average what the amount of time that algorithm will take. Worst case, okay, what is the maximum amount of time? Maximum. Okay, even if you take an n value equal to 100, even if you take n value equal to 1000, then obviously 4 into 1000 plus 4, 4004 is the large maximum time complexity this particular algorithm or piece of code will take. So we have 3 notations in the time complexity: best time complexity, best, average, and worst. Okay, all these 3 are nothing but asymptotic notations, asymptotic analysis that we will discuss tomorrow. Okay, no hurry with it. Okay, I hope everyone understand what is time complexity. Okay, space complexity we will not concern now. Space complexity మనం ఎందుకు క్యాలిక్యులేట్ చేయమంటే, యాజ్ ఎ యూజర్ వీఆర్ నాట్ రెస్పాన్సిబుల్ టు allocate memory for every line of a code what we written. It is responsibility of operating system to assign the memory. So we doesn't concern about the how much of memory required to store this program. I mean, we mainly focus on time because the time complexity will decides the efficiency of the algorithm. Okay, so in this class we discuss time complexity with a couple of examples. Okay, if anyone have any doubts in the example, you can able to ask me. We will discuss the asymptotic notation, that is best, worst, and average time complexities in the next class. Okay, anyone have any doubts? Anyone? I will take the attendance mark. In this meantime, you can able to ask if you have any doubts. Okay. 3, 6. Still absentees. Yeah, give your numbers now. 65. But those who are responded the attendance, I will take it. Otherwise, I consider as absent. 65 is there. 66. 66. 67.
Present, sir.
68. 68.
66 present, sir.
ఏం చేస్తున్నారండి? 68, 69, 69,
69 present, sir.
70, ఓకే అమ్మా, 70, 71, 71, 72,
Yes, sir.
73, 74. Amma, please make it fast.
Present, sir.
75, 76,
Present, sir.
77,
Present, sir.
78,
Present, sir.
79,
Present, sir.
80, Banuja, 80,
Present, sir.
81,
Present, sir.
82,
Present, sir.
80, 83,
Present, sir.
84,
Present, sir.
85, 86, 87,
Present, sir.
88,
Yes, sir.
89, 89, Jayant, 90,
Present, sir.
91,
Present, sir.
92, 93, 92, Aditya, 92, Aditya, 94,
Present, sir.
95, 96, 97,
Present, sir.
Divija, 98,
Present, sir.
Present, sir.
99,
Present, sir.
A0,
Present,
A1, A2, A3,
sir.
A4,
Present, sir.
A5, A5, Prasanna, A6,
Present, sir.
A7,
Present, sir.
A8, A9, B0,
Present, sir.
B1, B2, B3, B4, B5, B4, B5, okay, B5, B5, Lakshmi, B5 absent, B7, B7 is not there, B8,
Present, sir.
B9, okay, C0, Bhavya, C0, C1, C1 is not there, C2, C2, Sweta, C3,
Present, sir.
C4,
Present, sir.
C5, C6,
C5 present, sir.
okay, ma, okay, C7,
C7 present, sir.
C8, Uday Bhaskar,
Present, sir.
okay. See the absentee 65, 70, 89, 92, B5, B7, and C1. Okay. Okay. Now, if you have any doubts on how to find out the time complexity, okay, let me know in the next class. Then we will go for the asymptotic notations. Okay. Thank you, everyone. We will meet in the next session. One more thing. Okay, I will call Kirtana and Agnes. Okay, thank you. Sir, you can continue, sir. Sandeep, sir.
Okay, sir.